Hi, welcome back to another demo here. Today we're going to be talking about how to use the new Sharedv4 service from Portworx in a edge use case. So we're going to hook up an edge device with a Sharedv4 service Portworx volume to a core cluster running in EKS that also has some GPU nodes, so we can do some interesting scheduling. So we have a Kubernetes cluster here. Still get nodes. 4 nodes. One of them is a GPU node, so we can do a show labels grep GPU. We have one of them which comes up, which is a node type GPU storage node. And this is really so that we can schedule a AI sort of ML workload on this GPU node, which is running Portworx, so that it can do some modeling of the data that we're going to be working with. So one of the items that we want to show here is that we do in fact have Portworx running on all 4 of these nodes. It's using CSI. We do have a Sharedv4 volume service set up. So if you're not familiar with this service yet, check out our documentation on how to create Sharedv4 PVCs and specifically how to provision a Sharedv4 volume. There's a new optional parameter called Sharedv4 service type, which you can set to cluster IP to make it highly available within a Portworx and Kubernetes cluster or a load balancer. In this case, we're going to be using load balancer because we want our Sharedv4 volume to be accessible to an edge device, edge computing device. So here we have a storage class, which allows some of the IPs. It has some other information such as REPL2 and the Sharedv4 service type of load balancer. So what you can also do here is take a look at your volume by doing a volume list in your Portworx cluster. This volume should come up as v4 service. You should also be able to see some more information if you do a volume inspect within the cluster. So this is the volume inspect here. We can see that it is in fact using our service type Sharedv4 load balancer. It also gives you some Sharedv4 client mount options. So on our Raspberry Pi device where we're doing sort of the collection of temperature and humidity, we're going to use these to mount that device to it. And we can also see it's highly available and attached to our edge application. On the cluster here, we also have the edge application, which is connected to our Sharedv4 volume. And if you get the services in the cluster, you will see that it is running a special PX server, which gives you that sort of load balancer for the Sharedv4 service. Now, in that application, the Edge app, which is running in our core EKS cluster, we can run a DF, and we can see that it's mounting our shared volume locally. But it also allows you to export this volume, right? So in this case, we do have this Sharedv4 service with some access controls on it, and we've set it up so we can access this volume from our edge device. So we can head over to our Raspberry Pi, and from here issue a df-h. And what you can see here is actually this volume is mounted on mount/sensor data, and that sensor data is actually being used and written locally on this edge device in the office here, but it's connected from that EKS cluster that's running the edge application. So just to get a sense of what kind of data is in that is just some basic sensor data around temperature here, humidity, some date time parameters, and it does some basic sort of validation of this data at the edge. So it makes sure it's not sort of an outlier. It does some information validation, then writes it to this volume, this Portworx volume. And therefore, it's made available at the core EKS cluster to do more advanced things and run AI and ML workloads at the core. So that's sort of the setup of what our volume looks like. So we should be able to see the Python program. So we're running sort of the edge application, which is writing to this over and over again. We can actually follow this, and you can see it'll write new data points every so often. And so this is being basically streamed to our core cluster in EKS. And in that EKS cluster, we have that edge application. So that edge application is actually running a web application, which we can see this live data. So if we click the live data button here, what it's going to do is take a snapshot of the current state of that live data that's streamed from our edge device into this container, and it will produce some basic graphs of the temperature and humidity of this room that the edge device is on. And by doing this, we can get sort of a current picture of the last couple weeks of data. Here we can see that, generally it's around 70 to 75 degrees, and then the office was closed for a week, and so we see the eco-friendly HVAC system here makes the temperatures kind of go up while we're away, and then you come back and start using AC, and so the temperatures go down. You can see similar with humidity when the system's being used versus not used, and then it turns on again. So just this is sort of the live sensor data from there. Now, we said that this is running in our EKS cluster and it's GPU enabled, right? So what we can actually do is navigate to our node here, which is one of our EKS nodes that has the NVIDIA GPU enabled on it. And here there are sort of a monitoring process for that GPU. And here we can see nothing's happening. So if we go back over to our application and run prediction, this will kick off the ML workload, which runs Keras model machine learning with TensorFlow, and will produce a model. Now, what we should see is when we go back here, that after some initial validation of the data and sort of flattening of the data, it will kick off the model creation and start using this GPU. So there we go. You can see our Python program is now being recognized as being used by this GPU. And this just confirms that, we've taken Portworx volume from a core cluster in EKS that's GPU enabled with Sharedv4 volume services, connected it to a edge compute device on a Raspberry Pi, which records some data and streams it basically back to that volume, which makes the data available at the core again, where we can do some basic graphing and modeling, which this model, when it's complete, will actually do predictive modeling. So it'll try to predict the next, hour or so of temperature in the room and whether it'll increase or decrease. And so that's what this model is actually doing. So we're going to take a quick break while this model runs. And hopefully in just a few minutes, we'll see the output from this. All right, so here's our model. This is all the data that it learned from. This is sort of how it learned. And then it's predicting just a slight dip in the next hour or so from, 74 or 5 to 2 or 3. And that's really it. I mean, we're showing you that you can use Portworx at the edge using the Sharedv4 volume service connected to a core cluster or an edge compute node using the Sharedv4 service type of load balancer, and use it for all sorts of things, including maybe your edge use cases like this one. I hope you enjoyed and learned a few things. And until next time, take care.